Assalamualaikum and hi to everyone. So, I want to present to you guys about our problem-based learning for statistics for engineers NCB 20203. Our group member is Zulwal Ikram bin Yaakob, Amiruddin Harith bin Muhammad Hussein and Luqman bin Zainal Abidin. So, what is our problem statement? The problem given by collecting data to tables and contains the level of heavy equipment usage and the honest maintenance policy. This problem given to engineer after receiving replies from random sample of users and testify whether the variables independent or not at 1% level of significance. So the question is, in testing the null hypothesis that the level of heavy equipment usage and the honest maintenance policy are independent variables, a mechanical engineer received replies to her questionnaires from a random sample of users. The following summaries applies. So based on the tables given, the equipment usage is divided into three, which is light, moderate, and heavy. And it's also divided into three columns by calendar, by hours of operation, and as required. So this value is the value of observed value. So what is the question? The question is, at the 1% level of significance, should the engineer reject the null hypothesis? So first step, we need to determine the hypothesis. The hypothesis is divided into two types, which is null hypothesis and alternative hypothesis. For the null hypothesis is the level of heavy equipment usage and the owner maintenance policy are independent variables, and the alternative hypothesis is the level of heavy equipment usage and the owner's maintenance policy are not independent variables. So, we need to find the value of expected value. The expected value is equals to row total times with column total divided by the sample of size. So, as we can see here, 33 is the value of total row and 22 is the value of column total, and divided with the sample of size, which is 117, and we'll get 6.025. Then we calculate for the all expected value, then we sum it for the row and the column. Then, we need to find the chi-square value. The chi-square value is equals to summation of observed minus expected value squared divided by the expected value. So, as you can see here, this one is for the by calendar. The by calendar table is for the light, we will get the first column, we calculate the value of observed minus expected value. And the second column, we calculate for the observed minus expected value squared. And the third column, we calculate for the value observed minus expected value squared over expected value. And for the light one, it's equals to 5.4121. And for the moderate, the value is 0.1962. And the heavy one is 2.7176. We move to the column number 2, which is by hours of operation. It is the same formula we apply here, and the value of light is equals to 1.7345, and for the moderate is equals to 0.2185, and for heavy one is 2.8442. And we move to the third column, which is as required. And also we use the same formula to find the chi-square value. And the value of for light is 0.0863. The value for moderate is 0.5436. And the value of for heavy is equals to 0.2565. Then we total everything of the value of chi-squared value. We will get the value of 14.0095. Then we need to determine the value of degree of freedom. To find the value of degree of freedom is equals to rho minus 1 times with column minus 1, which is we have 3 row and we have 3 column. So 3 minus 1 times with 3 minus 1 is equals to 2 times 2. So we get 4 for the degree of freedom. So we look to the table of percentage point of the chi-square distribution. So basically the value of df is equals to 4 and the value of alpha is equals to 0.01. So we get from the table, we will get the value of alpha is equals to 13.28. So we can plot the graph. As we can see in the graph, we can see that the value of calculated value is more than the chi-square value. So for the hypothesis, the chi-square calculated, which is 14.0095, is greater than alpha, which is 13.28. So the H null is rejected. In the data collected, there is enough statistical evidence to reject HO, which is null hypothesis, and to believe that there is a relationship between the equipment usage and maintenance policy.